Okay, so this will be the fourth video in the series on factoring. So in the first video, we just talked about factoring out a GCF. Second video, we talked about factor by grouping, and that one's going to come in big time today, okay? So factor by grouping, that's where you have the four terms, you factor the left two terms, you factor the right two terms, and then you factor kind of overall. And then in the third video, we talked about factoring what we call quadratic trinomials, and I'll kind of remind you of what quadratic trinomials are in just a bit. But in that video, we basically looked at the constant and we found factors of the constant that would add up to be the coefficient of the linear term, or we would find factors of C that would have the sum of B. Okay, so, and again, that'll make a little bit more sense when I remind you of what a quadratic trinomial is. So the condition in the last video with factoring those quadratic trinomials was that the coefficient on the squared term, or A, was always 1, okay? Or it was something that could factor out so that the coefficient on the squared term was 1. In this video, the coefficient on the squared term is not going to be 1 anymore, and so it's a completely different process. Some of the things are going to be similar, like the idea of the signs, like how we would find factors of this one number that would add up to be another number. All of that's the same, but there's just a bigger process involved, okay? So let's go ahead and get started. Okay, let me get my pen. So let's review really quickly. So this is first of all going to be factoring quadratic trinomials. So they all have three terms where A does not equal 1. So let's review really quickly what a quadratic trinomial is. This is a quadratic trinomial. So quadratic trinomials are always going to be of the form ax squared plus bx plus c. A is always the coefficient of the squared term. B is always the coefficient of the linear term. And C is always the constant. The only real condition here is that A cannot equal 0. So when you have a quadratic trinomial, there has to be a squared term, because quadratic trinomials are what we call degree 2 trinomials, right? So A right here, this cannot be 0. If that is 0, that squared term disappears. Okay, now what we're going to be dealing with in this unit on factoring is we're going to be dealing with these quadratic trinomials where A is some number other than 1. So we already know it can't be 0, then it's no longer a quadratic trinomial. But outside of that, we want to make sure that these trinomials that we look at in this unit, the coefficient on the squared term isn't 1. In the previous video, we would always have something of the form x squared plus bx plus c. We would always have this kind of hidden coefficient here of 1. Well, in this video, we're going to have numbers there. Okay, so we in this video are going to have to look back at factor by grouping. Let me go back to black ink. Hold on. So I want you to review factor by grouping. So I've got an easy example here that we can look at just to remind ourselves, because it's going to be a huge part of what we do in this video. So let's say we have 3x squared minus 4x minus 3x plus 4. So with these, what we would do is we would split them down the middle, and then I would look at the left separate from the right. So looking at just the left, I have 3x squared minus 4x. Well, in this case, the GCF is just x. So I can divide each of these terms here by x, and what I'm left with is 3x minus 4, okay? So in that first term, 3x squared divided by x, I'm left with 3x. In the second term, negative 4x divided by x, I'm left with negative 4. On the right-hand side of this, I have a GCF. Well, I don't really have a GCF, but since that lead term is negative, I have to factor out a 1, so I'm going to write negative 1. And then I divide by negative 1. And I'm left with 3x minus 4. Negative 3x divided by negative 1 is positive 3x. And 4 divided by -1 is -4. So now you'll notice that the stuff inside parentheses is the same. That makes this our GCF. So I'm going to write down my new GCF, 3x minus 4. I do keep it in parentheses. And now I'm going to divide by 3x minus 4 on the left and the right of this problem. And on the left, 3x minus 4's cancel, and I'm left with x. On the right, 3x minus 4's cancel, and I'm left with -1. So that is factor by grouping, okay? It's a cool way of factoring. It's used when you have a situation where you have 4 terms that need to be factored, but there's no just overall GCF, okay? Now, let's look at what's going to happen here. So let's consider 2x plus 3 times x minus 5, okay? So if I look at 2x minus 3, what we would do is FOIL. Now, keep in mind, factoring is the process of undoing multiplication of polynomials. So factoring will undo the distributive property, and factoring will undo the FOIL method, okay? So we're going to go ahead and start with something that needs to be FOILed, and then I'll show you how in this unit we're going to work backwards, okay? So here I would get 2x times x, so 2x squared. I would then take 2x and multiply it by -5, where I would get -10x. Next, I would take this 3 and I would multiply it by x, so I get plus 3x. And then 3 times -5 is -15. And then we would go ahead and simplify. Okay. Now, in the previous video, we would have had a situation where the coefficient on the squared term was 1. And all we had to do was look at c, and we would find factors of c that would add to be the coefficient on the linear term, or what we call b. This is a little bit different because of this coefficient on the squared term. So what we do is the AC method. So I look at A and C and I multiply them. So 2 times -15 is -30. So instead of just looking at C, I multiply A and C, so the coefficient on the squared term and the constant, and then I find factors of that that'll add up to be the coefficient of the linear term. So I've got a product here, AC is -30. I need factors of -30 that will add to -7. So in order to get a product of -30, my factors have to be 1 positive, 1 negative, and I want the larger factor to be negative. That'll give me this sum of -7. So factors of 30 could be -30 and 1, -15 and 2, -10 and 3, or -6 and 5. So which pair of factors works? Which pair of factors, when added, would give me -7? Well, -10 and 3. So here's what I do. I break down this -7x into -10x and 3x, okay? And then everything else stays the same. So really all I've done is I've rearranged, I've rewritten this particular polynomial here as 2x squared minus 10x plus 3x minus 15. Well, look at what that is. This is exactly the same as what we ended up with when we started the FOIL method. So it's just that in-between step of the FOIL method, right? And notice now that the 10 and the 3, when added, give me the -7, okay? So there's a method to what's really going on there. So basically what we've done is we have found factors of AC, which is -30, and we found factors of that add up to be this middle term. So what we do is we rewrite that middle term as the sum of 2 different terms, all right, using those factors that we just found. And at this point, we factor by grouping. So I'm going to look at just the left. Well, on just the left, I have a GCF of 2x. So I'm going to factor out the 2x. And when I factor out the 2x, basically 2x squared divided by 2x is just x. And -10x divided by 2x is -5. All right. And then on the right-hand side, I have a GCF of 3. So I'm going to write down plus 3. And then when I divide by 3, I'm going to be left with x minus 5. 3x divided by 3 is x. Negative 15 divided by 3 is negative 5. And now look, the stuff in parentheses matches, so it's a GCF. So I come down here with my GCF, and then I'm going to divide by that GCF. And when I do that, the x minus 5's on the left cancel, leaving me with a 2x. The x minus 5's on the right cancel, leaving me with a plus 3. And what did I get here? Well, I got exactly what I had to begin with. So remember, factoring is always the process of undoing the FOIL method. So what we did is we started out by FOILing, and we got to this point right here. And then I showed you how we would reverse that and go right back to where we started, right here, okay? So the AC method is definitely a little bit more involved than what we did in the previous video, but it's not bad overall, okay? So let me go ahead and write out some steps for you. So the first thing we want to do is okay, sorry about that. I had a student join me on Zoom. Okay, so here are the steps to factoring quadratic trinomials where a is 1. Okay, the first thing you always want to look for is a GCF. Okay, so if there's a GCF, factor it out. Okay, the second thing we want to do is find AC. So you're literally going to take the coefficient on the squared term, you're going to multiply it by the constant. Okay, that's AC. Okay, sorry, another student stopped me on Zoom. Okay, so when you're factoring these quadratic trinomials where a is not 1, always look for a GCF first, find the product of a times c. And then what we want to do is we want to find factors of AC that have a sum of b. So remember, when you've got a quadratic trinomial, you've got ax squared plus bx plus c. So when I talk about a, b, and c, I'm talking about the coefficients of the squared term, the linear term, and then the constant. Okay, so once you find AC, you find factors of AC that have a sum of b, and then we want to rewrite the trinomial by breaking down bx into 2 terms using the factors from step 3. So those factors you find of AC that have a sum of b, basically you're going to rewrite that bx term as the sum of 2 terms using those factors in step 3. And then finally, once you do that, you factor by grouping. So this is why factor by grouping is such a big deal. It seems kind of like this random thing that we do, and then now it has a purpose, okay? So let's look at lots and lots and lots of examples, okay? So first example that I want to look at is 5x squared plus 17x plus 6. Okay, so we do not have a GCF here. There's nothing that we can factor out. We're stuck with that coefficient on the square term of 5. So we need to proceed by using the AC method. So remember, for the AC method, I've got the steps lined out right here beside. A times C is 5 times 6, or 30. Now, I need factors of 30 that are going to add up to give me 17. So in order to have 2 factors that multiply to give you a positive number like positive 30, both factors have to be positive or both factors have to be negative. And the sign on B, this plus sign right here on B, that tells me what those factors have to be. So again, if AC is positive, the factors of AC have to either both be positive or both be negative and the coefficient on the linear term tells us positive or negative. So in this case, we want positive factors of 30. So I could use 30 and 1, 15 and 2, 10 and 3, or 6 and 5. So of those pairs of factors of 30, which pair adds to 17? Well, 15 and 2. So what I'm going to do is I'm going to come over here and I'm going to rewrite my 17x as the sum of two factors, or the sum of two terms, using these factors that we found over here. So instead of 17x, I'm going to write it as 15x plus 2x. And then everything else in the polynomial stays the same. So the 5x squared and the 6 stay the same. Now we can factor by grouping. So if I look at just the left-hand side of this problem, the 5x squared and the 15x, I have a little GCF here of, let's see, 5x. So I'm going to write down my little miniature GCF. And then what I'm going to do is I'm going to divide by it. I'm going to divide both of these terms by 5x. Well, 5x squared divided by 5x is just x. 15x divided by 5x is plus 3. And then I'm done with everything on the left, and I'm going to move to the right. So looking at the right-hand side, 2x plus 6, I have a little GCF here of 2. So I'm going to write down plus 2, and then a set of parentheses. Then I divide. 2x divided by 2 is x, and then 6 divided by 2 is 3. So now notice the stuff in parentheses matches. That's your new GCF. So I get my new big GCF, write it down, and then write down an empty set of parentheses. And then what I do is I divide over here by the GCF of x plus 3. On the left-hand side of the problem, the 5x times x plus 3, well, the x plus 3's now cancel, leaving me with a 5x. On the right-hand side of the problem, the 2 times x plus 3, the x plus 3's cancel, leaving plus 2. And that's it. You're done at that point. So even though this is a lot more involved than what we did in the previous video, it's not really that difficult. We're just using things we already know how to do. The only difference here is you have to find AC first. All right. Now, the cool thing about these problems is you can always check your work. So I'm going to check by foiling. All right, so I have x plus 3 times 5x plus 2. I want to make sure that when I multiply this out, I get 5x squared plus 17x plus 6. So I start with x times 5x, which is 5x squared. So we're looking good so far. I then get x times 2, or plus 2x. I move to the 3, and now I want to look at 3 times 5x, which is 15x. And then 3 times 2 plus 6. So you can see right here, we already look like this line of the problem where we had, where we split up that 17x, but let's go ahead and simplify. So I get 5x squared, and then 2x and 15x simplify. And then I've got my plus 6. So there you have it. So that is factoring a quadratic trinomial where the coefficient on the squared term is not 1. All right. Let's look at some more examples. Keep these steps in mind, okay? If we need to, I can refer back, all right? So next up, let's say that we have 6x squared plus 13x minus 5, all right? There's no GCF, and I have a coefficient on the squared term that is not 1. So I'm going to take a times c, so 6 times negative 5, all right? So yet again, we get negative 30. I promise you'll get AC values that are not 30. It's just sort of been unfortunate luck so far. But what we need now is we need factors of negative 30 that add to 13. So AC is negative. This means the factors that we're looking for are going to be 1 positive, 1 negative. And because 13 here is positive, we want the larger factor to be positive, okay? So I could have 30 and negative 1. I could have 15 and negative 2, 10 and negative 3, or 6 and negative 5. So which pair of factors, when I add them, would give me 13? Well, 15, and negative 2. So I'm going to rewrite this. I've got my 6x squared. And then my 13x, I'm going to rewrite it as 15x minus 2x. And then I'm going to drop down the minus 5. And then I factor by grouping. So remember, when we factor by grouping, we split it left and right. Okay, so left and right here. So looking at the left-hand side, I have 6x squared plus 15x. So my GCF here is going to be 3x. So I'm going to divide each of these terms by 3x. Well, 6x squared divided by 3x, 3 goes into 6 2 times. And then x squared divided by x is just x. So 6x squared divided by 3x is 2x. And then 15x divided by 3x, the x's cancel. And then 15 divided by 3 is 5. All right. Now moving to the left-hand side, it appears as if we do not have a GCF, but you always have to factor something out, even if it's just a 1 or a negative 1. So in this particular case, I need to factor out a negative 1. So I divide each of these by negative 1. Negative 2x divided by negative 1 is positive 2x. Negative 5 divided by negative 1 is positive 5. And now you can see the stuff inside parentheses matches on the left and the right. That's our GCF. So I get 2x plus 5 and a set of parentheses. And then I'm going to divide left and right by the GCF of 2x plus 5. 2x plus 5's cancel left and right, leaving behind 3x minus 1. And that's it. It's kind of fun, right? Maybe not the worst thing you've ever seen. Let's try another one. So let's say for this example, I have 5x squared minus 37x plus 14. There's no GCF, so I just have to do the AC method. So 5 times 14 is 70. Okay, so A times C is 5 times 14, or 70. So now I need to find factors of 70 that'll add to negative 37. Now, AC is positive. When you have a positive AC, the two factors you're looking for either both have to be positive or they both have to be negative. And the coefficient on X tells us, since we want these to add up to negative 37, we need negative factors of 70. So I could have negative 70 and negative 1. I could have negative 35 and negative 2. Let's see, 70 is not divisible by 3. It's not divisible by 4. It is divisible by 5. We could have negative 14 and negative 5. 70 is not divisible by 6. It is divisible by 7. We could have negative 10 and 7. And that's pretty much where we're going to stop. Now, you don't have to go through this whole list. If you see the pair of factors that's going to work right away, don't worry yourself with going through the whole process. So I could have stopped here. All right, I see that negative 35 plus negative 2 is negative 37. So let's rewrite this polynomial. 5x squared stays the same, okay? But then I need to rewrite my negative 37x as negative 35x minus 2x. And then I'm going to drop down my plus 14. And now we just factor by grouping. So looking at the terms on the left, 5x squared minus 35x, I have a GCF of 5x. So I'm going to divide by 5x, both of those terms on the left. So 5x squared divided by 5x, well, the 5's cancel. The x in the denominator cancels one of the two x's in the numerator, leaving just plain old x. And then negative 35x divided by 5x, the x's cancel, and negative 35 divided by 5 is negative 7. Okay? So on the right-hand side of this problem, I've got negative 2x plus 14, and this is something we talked about in a couple of videos. If your lead term is negative, your GCF must be negative. So if we look at just 2x and 14, we can see that we have a GCF of 2. but my lead term is negative 2x. So I need to factor out a negative GCF here. So I'm going to come down here and I'm going to factor out a negative 2. So I'm going to write minus 2, and then I'm going to divide both of these terms by negative 2. So negative 2x divided by negative 2 is just x. And then 14 divided by negative 2 is negative 7. So what do you notice about the stuff in parentheses? Well, it matches. All right. So that means my big overall GCF is x minus 7. And I'm going to divide the left and the right by x minus 7. The x minus 7s are going to cancel, leaving 5x minus 2. And that's it. All right. If at any point you doubt your work, like you feel like it's just not working out right, FOIL your answer and see. When I FOIL x minus 7, so let's say we just go ahead and check this one. When I FOIL here, I would get x times 5x, which is 5x squared. X times negative 2 is negative 2x. Negative 7 times 5x is negative 35x. Negative 7 times negative 2 is 14. And when I simplify, look at what I get. I get exactly what I started with, okay? So if at any point you kind of doubt your work, check it. Do that FOIL and see that everything is working out correctly. Moving right along, let's say for this one, I have 6x squared plus 23x plus 20. Is this one going to work? Okay, so there's no overall GCF, so we start with the AC method. So A times C is 6 times 20, or 120. So we want factors of 120 that add to 23. So 120 is kind of a large number to start finding factors of. And what I would encourage you to do is just take that number and divide it by 2, 3, 4, 5, 6, 7, 8, 9, whatever, until you get through all of the possible pairs of factors of 120. So I do have a positive 120. That means both of my factors of 120 have to either be positive or negative. And this right here tells me that I'm looking for positive factors of 120. So we could have 120 and 1. We could have 60 and 2. We could have 40 and 3. We could have 30 and 4. Let's see, we could have, let's see, 25 and 5, 24 and 5. We could have 20 and 6. Let's see. 120 is not divisible by 70 or 7. It's divisible by 8. So we could have 15 and 8. Let's see. 120 is not divisible by 9. It is divisible by 10. And it's not divisible by 11. Okay. So anytime you get decimals, you just throw out that pair. Okay. When you get whole numbers, see if the pair works. So looking at this arithmetic right here, these pairs of factors, do any of them add to 23? Well, yeah, we've got this 15 and 8. 15 plus 8 is 23. So we rewrite this polynomial. And what I'm going to do is I'm going to break down my 23x, and I'm going to rewrite it as 15x plus 8x. It does not matter the order that you write those factors. I could have written this as 6x squared plus 8x plus 15x plus 20. That would be fine. The work in the middle when you're doing factor by grouping is going to look different, but the final answer is going to be the same. So it does not matter the order you write these factors as long as the sign in front of the factor is correct. Okay, so I split this down the middle and I start my factor by grouping. So looking at 6x squared and 15x, well, 6 and 15 have a 3 in common, and then we obviously have the x in both terms. I'm going to rewrite that because I'll end up running out of room. Let me scoot that over a little bit. So I've got 3x. There we go. All right, so I'm going to divide both terms on the left by 3x. Well, 6x squared divided by 3x is 2x. And then 15x divided by 3 is 5. All right. Now moving to the second half of the problem, I've got positive 8x plus 20. Well, 8 and 20 have a 4 in common, so I'm going to have a GCF of plus 4, and then I divide. Well, 8x divided by 4 is 2x. 20 divided by 4 is 5. So now you'll notice the stuff in parentheses, it does match. So that's our new GCF. So I get 2x plus 5. And then the second set of parentheses is always going to be the sum of those two smaller GCFs. But just in case you don't see it, you can show the work. 2x plus 5's cancel, and I'm left with 3x plus 4. And that's it. And again, if you doubt yourself at any point, just FOIL, check your work. All right. Let's look at this one right here. So for this next one, we have 20x plus, or 20x squared plus 6x minus 2. Now, one thing I want to point out is that in this case, we do have a GCF, okay? We have a GCF of 2 that we should go ahead and factor out right away, okay? So I'm going to go ahead and factor out my 2. So 20x squared divided by 2 is 10x squared. 6x divided by 2 is 3x, and negative 2 divided by 2 is negative 1. So factor out the GCF and then do your AC method, okay? So A in this case is 10, C is negative 2, or negative 1. So AC is 10 times negative 1, or negative 10. I need factors of negative 10 that add to 3. So when your AC is negative, that means one of your factors that you're looking for has to be positive, the other has to be negative. And the sign on B tells you what the larger factor is going to end up needing to be. So in this particular case, I need a positive and a negative factor of 10, and I want the larger factor to be positive. So I could have 10 and 1, or I could have 10 and negative 1, or I could have 5 and negative 2. So which pair adds to 3? Well, 5 and negative 2. So here's the tricky part. Don't lose your original GCF. So I just write it down every step I take. Okay? So inside parentheses, I have 10x squared. And then my 3x, I'm going to rewrite as 5x minus 2x. And then I'm going to drop down my minus 1. So now I do the factor by grouping. Okay, so I'm going to bring down that original GCF of 2. And then for 10x squared and 5x, I have a GCF of 5x. So I divide. Let's see, 10 divided by 5 is 2, x squared divided by x is x. And then 5x divided by 5x is 1. Okay, we can't get lazy and say those things cancel. They don't cancel, they just simplify to become a 1. Now on the left-hand side of the stuff inside brackets, I have negative 2x minus 1. So again, it looks like there's not a GCF, so I need to factor out either a 1 or a negative 1. Since my lead term is negative, I'm going to factor out a negative 1. So divide by negative 1. Negative 2x divided by negative 1 is positive 2x. And then negative 1 divided by negative 1 is plus 1. So if I look inside the brackets, the stuff inside parentheses matches. So here's how I'm going to do this. I'm going to write out my original GCF of 2. Then I'm going to write out that new bigger GCF that's underlined in red, the 2x plus 1. And then I'm going to divide all that out. So the 2x plus 1s end up canceling inside the brackets, and it's going to leave me with 5x minus 1. And there you have it. Just don't, if you have a GCF overall, don't forget it in your final answer, okay? Okay, next up, let's say that we have negative 10x squared plus 27x minus 11. Now, what's interesting about this one is that we have a negative lead term. And this is something that came up in 2 of the previous videos. Well, probably all 3 of the previous videos. If your lead term is negative, you have to factor out a negative. Okay. So if I don't have another if I don't have a GCF overall, I still have to factor out a -1. I can't factor using the AC method if my squared term is negative. So we're going to say that we have a GCF of -1. So I'm going to go ahead and factor out the -1. All it's really going to do is change my signs on the inside here. So instead of -10x squared, I'm going to get positive 10x squared. Then I'm going to get -27x, and then I'm going to get plus 11. And now we can do the AC method. Okay, so 10 times 11 is 110. Now, I do have a positive product there. AC is positive 110. So that means I'm looking for factors of 110 that are either both positive or both negative. And the sign on B tells me what those factors need to be. So in this case, both factors of 110 should be negative. So I could do -110 and -1. Okay. I could do -55 and -2. And again, this is another product like AC is 110. That's another kind of big one that you may not know the factors right off the top of your head. So just go through your calculator, divide by 2, divide by 3, divide by 4. So let's see, we're going to divide by 5. So here we get -22 and -5. Now, what I've done in the previous examples is I went ahead and I found all of the factors of AC, but I could go ahead and just stop here because what do you notice? I noticed that -22 and -5 add up to -27. So here's how this is going to play out. I'm going to bring down that original GCF of -1. And then inside parentheses, I'm going to break down my 27x as -22x minus 5x. And then the rest of the trinomial stays the same. Now I factor by grouping. And when I do this, I keep bringing down that original GCF of -1. And then looking at 10x squared and 22x, what I have in common here is 2x. So that's my GCF. So I'm going to divide each of these by 2x. So 10x squared divided by 2x is 5x. And then -22x divided by 2x is -11. Now, moving to the next half of the polynomial inside brackets, I have -5x plus 11. There doesn't appear to be a GCF, but the lead term is negative, so I need to factor out a -1. So I divide by -1. -5x divided by -1 is 5x. And 11 divided by -1 is -11. So notice the stuff in parentheses is the same. So what I do is I write down the original GCF of -1. A lot of times we don't put the 1. We just write the negative. If we have a GCF of -1, we just write a negative. And then I'm going to write down my next GCF of 5x minus 11. And then I divide. The 5x's cancel, leaving behind 2x minus 1. Don't lose that original negative that you factored out at the start, okay? So next up, I want to try to show you all different special cases that could come up, all right? Let's see. Next up, I've got 4x squared plus 21x y plus 5y squared. So this is something that came up in the previous video where you had the double variables. And basically all we did in the previous video is we started each set of parentheses with an x and we ended each set of parentheses in a y. It's even easier here because when you do the factor by grouping, everything kind of works itself out. So what we're going to do is we're going to ignore the fact that we have double variables and we're just going to go straight into the AC method. So A is 4, C is 5. So AC is 20. I do have a positive product. That means the factors I'm going to look for are both going to be positive or they're both going to be negative. And this right here tells me that they're both positive. So I could use 20 and 1. Well, I don't really have to go any further because what does 20 plus 1 end up being? Well, 21x. So what I'm going to do here is I'm going to rewrite this polynomial. But for 21x, I'm going to break it down into plus 20xy plus 1xy. And I will say a lot of times you don't even see the 1, you just see xy. Whoops. Now I can factor by grouping. So looking at the first two terms, I have a GCF of 4x. So I divide by 4x. Well, on the first part, 4x squared divided by 4x, the 4's cancel. And then x squared divided by x is just x. On the second term, the 20 divided by 4 is 5. The x's cancel, and I'm left with a y. All right. Now, moving to the next side of the problem, I have a GCF in both terms. I have a y, so the GCF is going to be plus y. And then I divide. Xy divided by y is x. And then 5y squared divided by y is just plus 5y. So notice now, the stuff in parentheses matches. That's my GCF. And then those two miniature GCFs are going to end up being the second polynomial, but let me just prove it to you. I divide by 5, or x, bless my heart, I divide by x plus 5y. X plus 5y's cancel, leaving behind that first little GCF of 4x plus the second GCF of y. And there you have it. So double variables, no big deal here. There's literally no work for you. Let's see. What if we had, let's say that we have 7x squared minus 62x minus 9. So there's no GCF. I jump straight to the AC method. So a times c is 7 times negative 9, or negative 63. Now, in this case, I have a negative product, okay? And with that negative product, I need factors that are one positive, one negative. And this right here, this negative 62, the coefficient of b, that tells me that I want my larger factor to be negative. So I would start with negative 63 and 1, and bam, that's the pair that's going to work. So I rewrite my polynomial. But what I'm going to do is I'm going to break down my negative 62x as negative 63x plus 1x, and then minus 9. I'm going to go ahead and start factor by grouping. 7x squared minus 63x, we have a GCF of 7x. When I divide, I get x minus 9. Now, on the right-hand side of this problem, there is no GCF, but remember, you have to factor something out, either a positive 1 or a negative 1. So I'm going to go ahead and factor out a positive 1. And when I divide, nothing's going to happen. I'm just going to be left with x minus 9. So the stuff in parentheses matches. That's my GCF. And then when I divide by the x minus 9s, they cancel. They really just become 1s. X minus 9 divided by x minus 9 is 1. 1 times 7x is 7x. And 1 times 1 is 1. So there you have it. Let's see here. I want to do like maybe 3 more, I think would work. How about this one? Let's say we have 3x squared plus 20x plus 12. All right. So there's no GCF overall. So I go ahead and I jump straight to the AC method. So I'm looking for 3 times 12, which is 36. All right. So I want factors of 36 that would add to 20. And because 36 is positive, both of my factors are going to either be positive or negative. And this plus 20 right here tells me they're both going to be positive. So I could try 36 and 1. I could try 18 and 2, and that happens to work. So I'm going to do 3x squared plus, remember, we're going to break down 20x as 18x plus 2x, and then plus 12. I factor by grouping. So looking at the first half of the problem, I have a GCF of 3x. When I divide these terms by 3x, let me fix this, it looks a little sloppy. When I divide both of those terms by 3x, well, 3x squared divided by 3x is just x, and then 18x divided by 3x is plus 6. Looking at the second half of the problem, I have a GCF of 2. When I divide each of those terms by 2, I'm left with x plus 6. So there you have your new GCF. So I get x plus 6. And then the second set of parentheses is going to be those miniature GCFs that we had to start. But just to prove it to you, I'm going to divide both sides by x plus 6. Well, x plus 6 divided by x plus 6 is 1. 1 times 3x is 3x. Again, x plus 6 divided by x plus 6 is 1. 1 times 2 is 2. So there you have it. Kind of fun. Let's try maybe 2 more and then we'll call it a day. So let's say that I have 12x squared minus 5x minus 6. All right, there's no GCF, so I'm going to jump straight to AC. So A times C is 12 times negative 6. All right, and 12 times negative 6 is negative 72. So I have a negative product here. That means the factors of negative 72 are either both, the factors of negative 72 need to be 1 negative, 1 positive. And this right here, this negative 5, tells me that I want my larger factor to be negative. So I could try negative 72 and 1. I could try negative 36 and 2. I could try negative 24 and 3. Let's see, 72 divided by 4. I could try negative 18 and 4. 72 is not divisible by 5. 72 is divisible by 6. So I could do negative 12 and 6. 7 doesn't go in, 8 does. I could do negative 9 and 8. Okay. Now, looking at these pairs of factors, the first pair, negative 72 and 1, adds up to negative 71, so that doesn't work. The next pair, negative 36 and 2, when I add that, I get negative 34, so that doesn't work. Negative 24 plus 3 is negative 21, that doesn't work. Negative 18 and 4 is negative 14, so that's out. Negative 12 and 6 is negative 6. It's close, but not exact, so that's out. And then negative 9 and 8 is negative 1, so that's out. So what do we do? Well, we would say that this is prime. Remember prime polynomials? If there are no factors of AC that have a sum of B, then we say the trinomial is prime. Now, this comes up, but not a ton. So you're not going to go through your homework and all of them are going to be prime. You might have a sprinkling of primes, but I do want you to know how to handle it when it comes up. Okay. Let's say that we do 1 more of these, and then we'll wrap up this video and we'll call it a day. So let's say we have 8x squared plus 14x minus 15. There's no GCF, so we jump straight to AC, which is 8 times negative 15. All right. And 8 times negative 15 is negative 120. Now, I do have a negative product here, so that means my factors of negative 120, one's going to be positive, one's going to be negative. And this positive on the 14x tells me that the larger factor is positive. So we could try 120 and negative 1. We could try 60 and negative 2. We could try 40 and negative 3, 30 and negative 4. Let's see, 120 divided by 5, I get 24. a -5, sorry about that. I get 20 and -6, and that'll work. So 20 plus -6 is 14. All right. So let's see, we rewrite this as 8x squared plus, and then I'm going to break down my 14x as plus 20x minus 6x, and then minus 15. I factor by grouping. Looking at the left-hand side, my GCF is going to be, let's see, 4x. When I divide by 4x, I get 2x plus 5. And then looking at the second half, I have -6x minus 15. Since my lead term, -6, is negative, I do want my GCF to be negative. So I'm going to factor out a -3. And when I divide by -3, -6x divided by -3 is going to be positive 2x. And then -15 divided by -3 is going to be plus 5. Excuse me. Let me get some water. All right, now notice the stuff in parentheses matches. So that's my big GCF, 2x plus 5. And then the little GCFs are going to go in the second set of parentheses. So I'm going to get 4x minus 3. But to prove it, we divide both sides by the GCF. And the 2x plus 5s cancel in both cases, leaving me with 4x minus 3. Okay, so that's it for that video. So basically, I did get interrupted twice with students asking questions, so there's a little bit of a lag where I had to pause the video, but otherwise, I think everything went well. Keep in mind, you need to be really good at factor by grouping. So if you're not really good at factor by grouping, go back, rewatch the factor by grouping video and kind of study that, okay? Second, the rules for factoring trinomials where the coefficient on the squared term is 1, they still apply, okay? So when we had those quadratic trinomials where a was 1, we basically just looked at c. But if you think about it, the coefficient on the squared term was 1, and then c, when you multiply 1 and c, you just get c. So it's very similar to the process. We can just take a shortcut with the previous video. So when the coefficient on the squared term is 1, you just find factors of c that have a sum of b. Here, where the coefficient of the squared term is not 1, what we have to do is we have to take a times c, and then we find factors of ac that have a sum of b. And what we do is we rewrite the polynomial. We break bx into 2 terms using those factors of ac that we found. And then you factor by grouping. So in this video, it's not that it's harder. It's just a longer process. It's stuff we already know how to do. It's just putting it all together. So each problem just has more steps. That's basically it. Be on the lookout for prime polynomials. Be on the lookout for polynomials that have a lead coefficient of -1. So even if your polynomial does not have a GCF, if that lead term is negative, you do have to factor out a -1 right off the bat. Be on the lookout for polynomials that have like 2 variables. It actually works out a little bit easier here. You don't have to remember anything. Okay. So overall, check for a GCF first, and then if the coefficient on the squared term is 1, it's easy. You can take that shortcut. You just find factors of c that add to b. If you still have a coefficient on the squared term, you have this longer process of the AC method, okay? Next up, I think we're going to start looking at special products. So we'll look at what are called perfect square trinomials. We'll look at binomials where you have the difference of perfect squares, and then separately the sum and difference of cubes. And then after we do those 3, we'll have wrapped up our factoring unit. All right, take care.